All right, this is part 2 of the Unit 1 review for Trig, looking at some of the extra examples. So if we're given an angle in standard position, which remember means centered at the origin with the x-axis as our starting side, and we go around this way, find the ending side, and we're kind of, theta is measured from that origin area. So if we're in that position, find two positive coterminal angles and two negative coterminal angles for the following. Now that means you went around a whole cycle and ended in the same place. So since a cycle is 360 degrees or 2 pi, that's how we're going to find these angles. So the first thing you need to do is make sure your angle is actually between 0 and 360 or between 0 and 2 pi. If not, you're going to have to adjust that first or you won't be able to find the correct answers. So both of these are. So 240 degrees, we would subtract 360 and get our first negative one. So it's very late, so I'm going to use my calculator. So that's negative 120 degrees. And we would take that and we would subtract 360 again. And we would get negative 480 degrees. So those are my two negative coterminal angles for part A. To get the positives, we add 360, which is 600 degrees for the first one. It looks like 6,000. That is degrees up there. And then 600 plus the 360 for the second one. So 960. For the radians, you're going to be adding and subtracting 2 pi. Now, because the denominator is a 4, you actually can think of this as just adding something over 4, which would be 8 pi over 4, or subtracting 8 pi over 4. And notice 7 pi over 4 is less than 8 pi over 4, so it is between 0 and 2 pi. So 7 pi over 4 minus 8 pi over 4 will give me one negative. That would be negative pi over 4. Take that one, subtract the 8 pi over 4 again. That would be negative 9 pi over 4. Go back to your original. Add the 8 pi over 4. So that's 15 pi over 4. Take that one and add another 8 pi over 4. Because remember, that's 2 pi. And that would be 23 pi over 4. And that's how you find your coterminal positive and negative angles. For number 2, you have two formulas here, and you have to use the fact that they use radians, and it has to be radius, those two things, radians and radius. So arc length is S equals R times theta, where that's radius and radians for theta. And then the area is 1/2 radius squared times theta. So first of all, we have degrees, so we need to convert that to radians to be able to use the formula. So times it by the pi over 180. So that's going to be 4 pi over 9 that we're going to be plugging in. And then this is not radius, it's diameter, so we need to divide by 2, so that's 108 centimeters. So for the first one, this is going to be 108 times 4 pi over 9. And it did say exact answer, so we're not going to go to decimal. So I believe 108 is divisible by 9, though, and then times that by 4. So it's 48 pi, and it's centimeters, because this is in centimeters, not centimeters squared, because this is the length. Find the exact area of the sector. We do 1/2. Our radius was 108 squared, and this would then be still 4 pi over 9. So we're going to square 108 first. And then I'm going to divide it by the 9 that's in the bottom of one of the fractions. And that divides evenly, so we're good. And I'm going to try to also divide it by this 2 that's out front. And then we still have to times it by the 4 that's on the top. So I took that squared part, divided it by both denominators, and then timesed it by the top. Now that doesn't work if it doesn't go in evenly. So you'd have to work it out differently. So this is 2592 pi, because that's still part of the answer, but this time it's centimeters squared. So that's what they mean when they want exact. Okay, we did one of these for 3, so we're going to look at the second one. Find the exact values of the 6 trig functions. We need to place this on the quadrants to find the missing side. So -5 and -12, that is in I'm just going to estimate. We're not really caring about exactness. But that's in quad 3. So you immediately draw a line to the origin, and then you draw a line to the x-axis. That's how you make your triangle. So this is a -5 and a -12, and we're looking for c. So -5 squared plus -12 squared equals c squared. That's 25 plus 144 equals c squared. That's 169 equals c squared, or c equals 13. Radius is always positive, or hypotenuse for us, when we're talking about these standard positions. So my other side is 13, so that means sine of theta, because remember this is my theta when we're drawing standard position, it's always referenced between the origin and the x-axis. So our line to the origin and our x-axis. So sine is opposite over hype, so that would be -12 over 13. Cosine of theta is adjacent over hype, so -5 over 13. Tangent is opposite over adjacent, which is -12 over -5. That turns into +12 over 5. And then remember, our reciprocals are just flipped. So -13 over 12 for cosecant. Secant is -13 over 5. And cotangent theta is 5 over 12. So there's all of those. So for 4, it's similar, but they didn't give us the same pieces of information. They did give us cotangent, which is nice because that does tell me something about my triangle. It doesn't tell me which of the values was negative, but when you know it's cotangent, cotangent is always the x over the y. So we know that the top value is an x and the bottom value is a y. We just don't know which one is positive and which one is negative. But I do know that cotangent is an overall negative here, and cosine is an overall positive. So if you think about your all science teachers are crazy, the cotangent family is negative in the sine family and the cosine family. So that means that we have to mark out tangent and all, because those are both places where cotangent would be positive. So I'm down to 2 quadrants. Cosine being greater than 0 means we'll be able to eliminate one more quadrant. So since cosine's family is positive down here in quad 4, we can eliminate quad 2. So we're drawing our picture in quad 4. The reason that's important is because here the x's are positive and the y's are negative. So this is really a +1 over a -7. So when we draw a picture from that, we know that our x value is a 1, our y value is a -7. We're still looking for our hypotenuse. So this would be 1 squared plus -7 squared equals c squared. So remember, this is for cosine, by the way. So this is 50 equals c squared. So that would be square root of 50, and that reduces to square root of 25 and square root of 2. So 5 on the square root of 2. So this side down here is 5 on the square root of 2. So in terms of my theta, -7 is opposite to it, 1 is adjacent to it, and 5 square root of 2 is the height. So we're supposed to find the remaining trig functions. Now I already knew tangent, because if you have cotangent, tangent's just the reciprocal of that. That's -7 over 1, so it's just -7. But we need to find the other 4. So sine is going to be opposite over hype, so that's -7 over 5 square root of 2. We'll rationalize, so that is -7 square root of 2 over 5 times 2, so that's going to be 10. Then we would do cosecant from that, because that flips to 10 over -7 square root of 2. Rationalize again, and then it reduces because you get a 14 in the bottom. That's going to be -5 square root of 2 over 7. Now I would have been better off to flip this original part right here, because that would have kept me from rationalizing that. So this is my sine, this is my cosecant, here's my tangent, here's my cotangent. So I just need cosine and secant. Cosine is adjacent over hype, so 1 over 5 square root of 2. So if I rationalize the bottom, that is square root of 2 over 10. And then I would just flip the original format to get secant. That's a little bit quicker. So that's going to be 5 square root of 2 over 1, which is just 5 square root of 2. So that's how you find all your trig fit ratios when you're given a 1 fraction and a sign, which you do also know sign about this because this tells you if it's positive or negative just by what kind of fraction you have. But then you're also given a second sign informational thing to help you pick the right quadrant. Okay, for part 5 or number 5, I couldn't remember if we did A in class, so I'm going to skip it. But it's one of those, I just don't remember if we did it together or not. If you still need help with it, you can email me. But hopefully what we do on B, C, and D will be fine. So we're finding the exact values of theta that satisfy the following equation from 0 to 4 pi. That's the important part here, from 0 to 4 pi. So when we look at this first one, part B, cosine of theta is negative square root of 2 over 2. Now, that has to do with a 45-degree angle, right, of some kind, a reference angle. Because cosine only equals this when the reference angle is 45 degrees. And also we can think about what signs cosine has. All science teachers are crazy. So we know it's a 45-degree reference angle, and we're wanting it in radians, so that means it's going to be pi over 4, or something with a pi over 4 in it. So cosine is only negative in a couple quadrants. It's not negative here because that's all. It's not negative here because that is the place where cosine's family is positive. So it has to be in quad 2 and 3. So if we think about what that would look like here, so 45-degree angle, we have to think about that in terms of radians. So remember, radians for 45 degrees, you go pi over 4, 2 pi over 4. This is 3 pi over 4. So that's my first answer for B. So theta, one of the answers for it is 3 pi over 4, because that's where we would have a cosine value of negative 2, square root of 2 over 2. The other place happens down here. It's also 45 degrees. So if this was 3 pi over 4 right here, this is 4 pi over 4, and this would be 5 pi over 4. Now, if we map around again, that's also going to give me another one between, because if you 0 to 4 pi is 2 cycles all the way around the circle. So you just take these two answers and you add 2 pi to them. That'll get you around the circle again, which we know that 2 pi can be written as 8 pi over 4 to be common denominator. So this is 11 pi over 4, and this would be 8 pi over 4 again if we're going to add it, and that would be 13 pi over 4. So 11 pi over 4 is the coterminal with the first one, and 13 pi over 4 is coterminal with the second one. So that's all the places that theta can equal negative square root of 2 over 2 between 0 and 4 pi. So let's talk about the next two because they're a little bit more interesting and not as, I think, straightforward. The cosecant one, the reason that causes people problems is they don't remember cosecant and secant from the top of their head. So the first thing I would do with C is I would rewrite it as a sine problem. 1 over sine theta equals 2, because that's now cosecant written as sine. And then we can say, okay, let's cross multiply. That would be 1 equals 2 sine theta. Divide by 2. 1/2 equals sine theta. That's really what they're asking for. They're asking for when will sine be a half. And we know that because that's based on our unit circle. So remember, all science teachers crazy. So sine is a positive 1/2 would happen in either quad 1 or quad 2. It's not going to happen in 3 or 4. So we have to remember, when is sine 1/2? Well, that means that the y value is shorter. So you're going to be closer to the x-axis. So if this is 1/2, this has to be square root of 3 over 2. So this one is the 30 degrees, which means it is pi over 6. So both of these are going to be reference angles of pi over 6, but what we care about is what is this if you measure it from 0. So this would be 5 pi over 6. And remember, I count by 30 degrees at a time to find that. So one of my answers is pi over 6. Another one is 5 pi over 6, and then we add 2 pi to these. When you add 2 pi and you're dealing with 6's, you add 12 pi over 6. So that's, remember, 2 pi right here. So if I add 2 pi to this, that would make this 13 pi over 6. And if I add 12 pi over 6 to this one, that makes it 17 pi over 6. So there are my 4 answers for part C. And then the final one in this group is the one with secant equals 1. Okay, so when does secant of theta equal 1? If you think about it as 1 over cosine, because that's a little easier, then that's still just going to be 1. So cosine theta equals 1. And that's only going to happen in a quadrantal angle. So remember, you only equal 1 or negative 1 at those quadrantal angles. Oops, I wrote that backwards. So this one down here is 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1. Now, in this case, cosine theta being equal to 1 is asking when x is positive 1. That's what that really says, because remember, cosine is x when you're on the unit circle. So that only happens here, okay? Now, the problem with that is that a lot of people want to answer pi as well, but pi is a negative 1 over here for cosine. And they want to answer this one because they see a 1, but remember, that's y being 1. So that's actually when sine theta is equal to 1. So for this is at 0. Now that means it also happens at 2 pi. And if we add 2 pi again, it happens at 4 pi. So it happens at those 3 measurements. 0 is the beginning, 2 pi is after one cycle, 4 pi is after another cycle. So that one doesn't require as much if you know what they're talking about. All right, so let's look at the next one. This says find the exact values of theta that satisfy the following equation in the interval, oops, minimize that on accident, negative pi over 2 to 3 pi over 2. So this is a little different because we're talking about, so let me mark what this is saying. The way they tell you to write your interval means that's how you're going to report your angles. So negative pi over 2 is down here, but that's also 3 pi over 2. So we're actually saying go around this way, and you report your angle as if it was from 0 to 3 pi over 2 would be okay, or from 0 into the negatives down to negative pi over 2. So when we say cotangent equals negative 1, so I'm going to do this one. Cotangent equals negative 1, we have to look at, and I don't think I did tangent. Let's go ahead and add both of them, sorry. Let's do tangent of theta equals square root of 3 over 3. So that happens when, if we draw that, that was actually a 1 over the square root of 3. So remember, that happens when you have either a 30, 60, 90 triangle, because you're getting a 1/2 and a square root of 3 kind of matched together. So if you think about before this was rationalized, it was 1 over the square root of 3, which meant that we had a 1/2 and a square root of 3 over 2. And that was our y, and this was our x. Now, you don't have to engineer it that way. That just helps me because then I know exactly which triangle I'm dealing with, because this is a 30, 60, 90, and we are positive for tangent. So all science teachers are crazy. Tangent is positive in this quadrant and in this quadrant. So if we draw a triangle, and we know that our y value is 1/2, and our x value is square root of 3 over 2. So that means we're dealing with, this is 60 because it's always across from square root of 3 over 2. This is 30. So we're looking at pi over 6 right there. So this is pi over 6. So that's one angle. Down here, we would report this one, still 30 degrees here, but this is 6 pi over 6, so that's 7 pi over 6. So that would be pi over 6 and 7 pi over 6. And both of those fall between negative pi over 2 to 3 pi over 2. So that would be for the A part one. Now, I did say that you didn't have to do it my way of drawing the triangle. The hard part about this one, if you don't know what angle or what that reduced from, is you have to draw out a picture of just kind of a random triangle theta with a right angle, and you know that it's opposite over adjacent like this. And if you do Pythagorean theorem, that would be 3 squared is 9. That would just be 3. That would be 12. You end up getting something funny up here. You get square root of 12, which is 2 on the square root of 3. And notice that doesn't look like any of our triangles that we've been doing. So you actually end up dividing everything by a 2 square root of 3. You force this to be 1. So I kind of wanted to show you how I knew that that was this triangle. So that makes this top part 1. That makes this one 1/2. And this ends up getting rationalized, and it ends up being square root of 3 over 2. So it's kind of hard if you have it in this format, if you aren't already aware that that is a ratio, because it's tangent of the 1/2 and the square root of 3 over 2. So I just wanted you to realize I didn't pull that out of thin air. I'm just very familiar with that. Cotangent of theta being -1 should be a little different though, because for it to be -1, remember that is cotangent of theta is when you have x over y. So that meant that you had to have something over itself for that to be -1. So for x and y to be exactly the same, that means you're dealing with a square root of 2 over 2 and a square root of 2 over 2, and one of them is negative. Now, by the way, you could be working some of these on your calculator. The only problem is that they don't give it to you always in the nice radians. So that's why I'm trying not to do that, because they did, I believe, want exact values. Yeah, when you want exact values, you don't want to use the calculator, because if you give us a decimal, that's not exact. So this is going to be square root of 2 over 2 and square root of 2 over 2. That's the only way this x over y could turn into a 1, and we don't know which one's negative until we look at our quadrants. So if you think about your quadrants, all science teachers crazy. Cotangent is the tangent family, so that's when it's positive, which is not what I want. So it's also positive here. I don't want that. What we want is when cotangent and tangent are negative, which would be in quad 2 and in quad 4. So that's going to be 45-degree angles when you're in those quadrants, because that's the only time you get square root of 2 over 2. So this is a 45-degree angle, and that means that my x is negative here and my y is positive. So that's one scenario. And then also, if it's 45 degrees this way, when my x is positive, but my y is negative. Those are the two scenarios where we could get a stacked value of -1. Now, what does that mean in terms of our answer? Well, this is supposed to be in radians. So this is, remember, pi over 4, 2 pi over 4, 3 pi over 4. So one of my thetas is 3 pi over 4. Unfortunately, you can't just keep counting around this way, because they told us to stop at 3 pi over 2. To get this one, you count down 1, so negative pi over 4. So you have to be aware of how they've stated your interval. If they say your interval can only go between such and such number to such and such number, the answers you report have to be in that interval. Okay, let's look at 7. 7 is requiring the use of the calculator, so we're going to make sure we know how to do these correctly. And I think I'll just go ahead and do all three. So it says approximate to the nearest 0.1 degree all angles theta in the interval 0 to 360 that satisfy the following equations. So when you're doing these, you do still need to remember your all science teachers are crazy, because that'll help us pick out whether or not we have all of our answers, which we usually don't. So all science teachers crazy. This says sine is negative. Sine is negative down in quad 3 and in quad 4. So this is for a part. So sine is negative in those two quadrants. So when I use my calculator, I'm going to use the inverse sine button. Now I believe in mine I have to type in the numbers first. Make it negative. And then we're going to take the inverse sine of that. That's that sine to the -1 looking thing. And we'll hit enter on that. So -33.1. So this is approximately -33.1 degrees. Now that right there, remember, is telling me what this measures down. I also know that I'm going to have a 33.1 degree reference angle anywhere that we have a matching quadrant, or in other words, the sine matches what it's supposed to. So for this one, we would do 360 minus the 33.1. That's how we would find that angle, because we want to report it from 0 to 360. And for this one, you would do 180 plus 33.1, because it's a little bit past the 180. So 180 plus 33.1 is 213.1 degrees. And 360 minus the 33.1. is 326.9 degrees. So that one is for A part. Okay, let's look at B. So for B, we're doing a tangent. So we do have a button for inverse tan. So theta, and notice that tan is positive in this problem. That'll help us in a minute when we draw a picture. So we're looking for the inverse tan of 2.5467. So we're going to do that on our calculator first. Make sure you are in degrees if your directions say you're going from 0 to 360. I'm in degrees. I don't want to be in radians or grad. So 2.5467, and we're doing inverse tan of that. That's 68.6. So that's going to be my reference angle. Now, tangent is positive because my ratio was positive in quad 1 and quad 3 because you get negatives over negatives here. So that means that this is a 68.6 degree angle. That actually is an answer because that is its measurement from 0 to 360. But on this one, we're going to have to add it from 180 plus that because it's bigger than 180. So 180 plus the 68.6 is 248.6. So 68.6 and 248.6. Okay, and then the final one for this group right here is secant. Equals negative 1.6681. I would go ahead and flip this. This is 1 over cosine. And the reason for that is you don't have an inverse cosine or secant button on your calculator. Now, here's something interesting. Oh, sorry, I don't flip the other side. Not yet. Just very tired. So this is like this. All I did was replace secant with 1 over cosine. If you have a fraction, 1 on each side, and you want to flip one of them, you flip the other to compensate as well. So this is actually 1 over that. So we're going to type it in as the reciprocal. So when we go solve for theta, it would be cosine inverse of the fraction. So let's type that in. So the first thing I'm going to do is 1 divided by parentheses 1.6681, which is negative, close parentheses, which it's not letting me do. So I had to go ahead and hit enter on mine, and then I'm going to do inverse cosine. So I'm getting 126.8. Now we've got to think, this was secant being negative. Secant, remember, is the same family as cosine. So all science teachers crazy. This came from my other part up there. So when we're talking about all science teachers are crazy and we want to know when was secant or cosine negative, essentially, that is in quad 2 and quad 3 because cosine is positive in both of these. So we're looking at a measurement here and a measurement here. Now this actually is 126.8. The neat thing about the inverse of cosine is it goes from 0 to pi. So that is this first angle. We've already got that one. But we don't know the reference angle. So this is why this one's a little harder. The reference angle is what we need to figure out this angle down here. So if we take 180 minus the 126.8, that will tell us this reference angle here, which was 53.2, which means this angle down here is a mirror image of that. So it's also 53.2. So to find our second one, we add 180, which is 1 full half, plus the 53.2. So I'm getting, which I can't add in my head. No, sorry. Don't add in your head. It would be 2 point, and then that would be 3, so 233.2 degrees. So yeah, that one's a little trickier because you have to flip it to get it a reciprocal, which means you flip this. To get it in regular format, you use the inverse of the fraction. And then because cosine goes from 0 to pi, where the other ones were in quad 1 and 4 when they give us the measurements, That means this was already our quad 2 angle, but to find our other one, we had to find that reference angle. So a little bit trickier there. Okay, for 8, we're doing the same thing, but we're in radians. Because notice they say to the nearest radian. So we want to make sure we put our calculator in the correct format. So when we do the cosine, remember cosine is going to give me 0 to pi. Cosecant and cotangent, remember, are the relationship of sine and tangent. Sine and tangent, your calculator only gives you negative pi over 2 to pi over 2. So we know that this guy is either going to be in quad 1 or 2, depending on what it tells us. And these two are going to be in quad 1 or 4. We'll still have to find the other answer in the other quad. So let's change our calculator to radians. And we're doing inverse cosine of the 0.5460. 0.5460 inverse cosine, that's 0.9932, which we'll call that 0.99. Now that is, remember, not my final answer always. We have to make sure we are getting the right answers. So remember, cosine is positive in quads 1 and 4. So 0.99, if you know what pi over 2 is, just so you have a reference, pi divided by 2 is 1.57. That kind of helps. So 0.99 is in the correct quad right here. So that is a good answer. So that would be in radians. That's a good answer. So remember, this angle doesn't always match up. It could be a reference angle. So that one's good. And then we need a matching 0.99 down here, but we're getting it from subtracting it from 2 pi. So 2 pi is about 6.28, but you can type it down on your calculator. And then we minus the 0.99. It's 5.29. So this one down here would be 5.29. So that's the one in quad 4 and quad 1. Because that's everywhere that cosine could be positive. So for cosecant, we're going to look at, so just for make sure I write this over here, this is what the calculator tells you. We always have to find both answers. For cosecant, remember, that's 1 over sine. So that means sine theta is 1 over this. And that's how we're going to do our inverse. So sine inverse of this fraction. Okay? So 1 divided by 2.5467. That is 0.39, blah, 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 blah. But we're going to take the inverse sine of that in radians. Make sure you're in radians. So that's 0.40. Okay, so we need to think about, are we in the right locations for this? So sine and cosecant, this is positive as well. They are positive in quad 1 and quad 2. All science teachers are crazy. So the 0.40, since we said this was 1.57 right here, and remember this is 3.14 and 6.28 over here. That's radians as decimals. That kind of helps. So the 0.4 is definitely over here in quad 1, which is one of the answers I was looking for. So that's good. But then I also need a matching 0.4 here. So I'm going to do pi minus 0.4 to get that decimal. So pi minus 0.4 is 2.74. So there's that answer. Okay, and then C, which I'm running out of room, is cotangent of theta, which we know as tangent. If we're going to use our calculator, we flip it essentially to make it tangent. And we're going to then take the inverse of that. Okay, and then remember, tangent, all science teachers crazy. We want to know when it is negative. So that's going to be in quad 2 and quad 4. So we will get the quad 4 one because that's what tangent always reports as, is either 1 or 4. So if we do our signs right, so 1 divided by 1.6681, it's a negative, and then inverse tan, that gives me negative 0.54. Now this is where this one's a little bit harder because that's not how we want to report that. If it's in quad 4, we want to report it between 0 and 2 pi, not negative 2 pi. So we're going to do 2 pi minus that 0.54 to get the actual measure. So 5.74. So 2 pi minus the 0.54 came out to 5.74. Okay, so that's this quadrant. This is also a 0.54 reference angle, and we can find it by doing pi minus that because it's a little bit less than pi. So pi minus 0.54. And that one is 2.60. All right, that's the end of that question. I know that was a little hard to read, that got a little bit messy, but essentially your calculator only gives you one of these. There will always be another quadrant where that ratio could either be positive or negative. All right, and that leads us into our last question on the review. Sorry this is a long-winded video, but wanted to make sure you saw each example possibility worked out. So these last two are graphing the transformations of the trig functions, sine and cosine. We're figuring out the amplitude, the period, the phase shift. There's no vertical shifts in these, and then we're graphing, it looks like one period of the graph listing the 5 key points. So we don't even have to repeat the period over and over again. So that's nice. So this first one is a sine graph. That's important to note first. You guys remember in class I graphed one of them wrong because I wasn't paying attention. So that means the general shape of my graph usually looks something like this. This is just sine of x from 0 to 2 pi. And remember, this is a height of 1 and negative 1. Okay, so just a rough guideline. So our amplitude is found by taking the absolute value of the number out front, which is just going to be 7. That means since we don't have any vertical shifts, the lowest this graph gets is negative 7, and the highest it gets is positive 7. My period is found by taking 2 pi and dividing it by the number in front of x, which is the b, and you take absolute value of that in case it's negative. So 2 pi divided by 1/2 times both top and bottom by 2, this is actually 4 pi. So my amplitude is 7, my period is 4 pi, and I do have a phase shift. The best way to deal with the phase shift I've found is just to set the part inside the parentheses between the 0 and 2 pi, since that's the normal period of sine, 0 to 2 pi. I would multiply everything by 4 to get rid of that denominator. So that's going to be 0. 4 divided by 2 is 2x. 4 times the negative pi over 4 would just be negative pi. And then 8 pi. So I multiplied everything by 4. Add pi to all three sides. So I have pi is less than or equal to 2x, less than or equal to 9 pi, divided by 2. Now the reason I like this is that tells me the start and end of my graph, and the phase shift is the first number. So my phase shift is going to be right pi over 2 since it's a positive. Okay, so we take all of that information and we try to draw a graph. So I'm going to try to make this small because I don't have a lot of room. So let's say we're going to count by 2's on our y-axis. So 2, 4, 6, negative 2, negative 4, negative 6. So obviously 7 will be a little bit below and above those. We have pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, because that'd be 6 pi over 2, 7 pi over 2, 8 pi over 2 is 4 pi, and I need to go all the way up to 9 pi over 2, so this would be 9 pi over 2. So see, this tells me how far I need to label if I have my start and ending. Now notice this is 4 pi, so this is going to be much more stretched out horizontally than our normal sine. And it doesn't start, remember, at 0, 0. It starts at pi over 4, or excuse me, pi over 2. So pi over 2 is the starting point. 9 pi over 2 is the ending point. So I'm matching up those points there. And halfway between those is when it's going to be in the middle again. So notice there's 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. So at that point, we're also there. We don't have a flip upside down since this is a positive 7, so we're going to go up to positive 7 first, and then down to negative 7 halfway. So notice I found the halfway point between these two. They're all equally dispersed like that. Now, I don't remember, did it say to list the points? Yes, list the 5 key points. So I would just write them on your graph. This is pi over 2, comma 0. This is 3 pi over 2, comma 7. This is 5 pi over 2, comma 0. 7 pi over 2, negative 7. And 9 pi over 2, 0. So there are all 5 of those points. Okay, for the other one, and the last one to do, it's the cosine transformation. It does not want to stay. So with cosine, remember, you're doing a different shape slightly. Still a wave, but it starts differently. So the typical cosine graph, here's 1, here's negative 1, here's the x-axis. At 0, you start up at 1, you go down at pi, you're down at negative 1, and by the time you get back up to 2 pi, you're back up. Now that's traditional cosine. Our amplitude here is absolute value of negative 4, which means it's 4. So we're going from negative 4 to 4, and because this is negative, we're going to be flipped. So we're actually going to start down first, go up, and then come back down. So this is going to be what we're graphing. And then our period is 2 pi divided by absolute value of b, which would just be 2, so that's pi. Our phase shift we find by putting this in between 0 and 2 pi, since that's the normal period. I would multiply everything by 3. So that's 6x, that's pi, that's 6 pi. Subtract the pi's from the middle, and then divide everything by 6. So this is a starting value of negative pi over 6 and an ending value of 5 pi over 6 for one cycle. So my phase shift is that we're going left pi over 6. Okay, so let's set up what we know. So I have 2 and 4 and negative 2 and negative 4. We need a negative pi over 6, then 0, then pi over 6. We're just going to count by pi over 6's. 2 pi over 6 is, remember, pi over 3. 3 pi over 6 would be pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6. That's going to be the ending of my period. Okay, so I just needed to make sure all of those values showed up equally spaced. Okay, now remember, this is going to be upside down. So at negative pi over 6, we're actually going to start down at negative 4 instead of up at positive 4. At 0, we need to do our ending point. 5 pi over 6, we're also going to be down. Halfway between these, we're going to be completely up, because that's what happens when it's flipped. So this is 1, 2, 3, 4, 5, 6. So we go 3. So 1, 2, 3. So pi over 3 is the middle, and it's not on the x-axis. Sorry. Too late. So pi over 3 is going to be up at positive 4. So notice it's kind of weird here because there's only 2 spots in between these. So we're actually going to go halfway in between for our x-intercepts. And I'll show you how you find out what points those are. It's not too bad. So this is the point, negative pi over 6, negative 4. This is, we can do the ones we know, pi over 3, 4. This is 5 pi over 6, negative 4. So we're wondering what these points are. I know they end in 0, but what's the x value? So notice there's a pi over 2 and a 2 pi over 3 that they're in between. If you add those together and then cut the answer in half, that will be that middle value. So we need a common denominator, so times this by 3, times this by 2, and you have calculators too, so that is 7 pi over 6, and if we cut that in half, that means you times it by half, so that's 7 pi over 12 actually. So that's a little difficult. And this one would be halfway between 0 and pi over 6. That's actually just pi over 12, comma 0. Because you just have pi over 6 minus 0, which is pi over 6, and then you cut it in half. Or you add it to 0 and you still get pi over 6. So yeah, that's the end of that one's graph. So the 5 points are a little hard when they cross at a weird place like that. But you can always, if you know it's crossing in between two values, you can add them and then cut that answer in half. And that will give you that x value. And that's the end of the review.